solve the system of equations, you may use either substitution, elimination, or the equal values method. Your work must be neat, clear, and easy to follow. So let's look at part A first. For this particular system, as I'm looking at it, it's a prime candidate for elimination because, as we can see, the y's are already set up. So remember, an equation saying that the left and the right-hand side are equal. So essentially what I have here is the left and the right-hand side of the top equation are equal, and the left and the right-hand side of the bottom of the equation are equal. So I'm essentially adding equal things to equal things, and I get a new equation. When I combine these in this fashion, the right-hand side becomes the number 20, and the left-hand side becomes a 5x. Notice that when I combine the positive y and the negative y, it equals 0. So that's pretty straightforward because now all of a sudden x is the number 4. Now that I know x is 4, I now use that information to figure out what y is, and I'm going to use the top equation. It tells me that if I take twice x plus y, I will get 15. Well, I just figured out that x is the number 4, so I'm going to look at 2 times 4 plus y is 15. 8 plus y is 15. Therefore, y has to be 15 minus 8, or 7. So when you get these two values, right, your solution should look like this. It is an x value of 4 and a y value of 7. This is an ordered pair. The ordered pair is the solution for 7. If you were to think about it, each of these is an equation, and what we're saying is the point where those equations intersect, right? If I was to graph them, the Cartesian coordinate plane is the point 4, 7. Let's take a look at B. As I look at B, elimination doesn't look quite as attractive, but I think I'm going to go ahead and use it anyways. I'm going to multiply this bottom equation through by a positive 8. It's a fairly large number, but when I do it, my y's will cancel again because I'll have an 8y on the one hand, and 8y plus negative 8y will be 0. So let's go ahead and multiply this second equation through by 8, and it becomes a 40 times x minus an 8y equals negative 24. The other equation I'm just going to rewrite below it, right? It is 3x plus 8y, and that equals a positive 24. Now when I combine these over on the right-hand side, negative 24 and 24 is 0, and negative 8y and a positive 8y is also 0. And then I end up with a 40x plus 3x, so that's a 43x. So my equation is 43 times some number equals 0. Well, the only number that could be is 0 itself, so I'm dividing both sides by 43, and I get that x is equal to 0. So I know x. Now let's go ahead and figure out what y is. I think I'll use this second equation to calculate y. So again, 5 times x minus y equals negative 3. So if I simplify that, that's just simply the opposite of y is negative 3. And if I divide both sides of that by negative 1, or multiply both sides by negative 1, I get that y is the number 3. So again, as an ordered pair, my solution is x is 0, y is 3. Cooper is selling pens and mechanical pencils. He's selling the pens for $1.50 and mechanical pencils for $1.95. He has sold 95 items and has collected $171.75. Find the number of pens and mechanical pencils that Cooper has sold. Write a let statement to show which variables you are using and what they represent. So this one, there was plenty of room, right? I could say, let's let... I went with P equals the number of pencils. And then, of course, our problem is that the number of pens also would be great as a P. So I went ahead and went with N. Maybe I should have used M for mechanical. No, these are the pens. So N is the number of pens. Now at this point, I'm going to refer to this at the end in case I make a mistake and I forget what these are. Okay, so there's two equations I can write. One of them deals with quantity and the other one deals with value, right? It's certainly the case that if I add up the number of pencils that I sold plus and the number of pens, I would get Cooper sold a total of 95 items. The other equation does involve value, and I think that the pens, which we are representing with the number n, if I multiply the number of pens sold by $1.50, and I add to that P times which is the number, that P is the number of pencils sold, and each one of the mechanical pencils was $1.95, I would get $171.75. So I apologize, there is not enough room to really do this problem here and show all of the work. But I'm going to go ahead and proceed anyways. The method that I chose was elimination, and I actually chose to get P alone in the first equation. So P would have to equal, I could say 95 minus N. And if I'm going to use that, right, this 95 minus N is P. And you can see I'm just going to go ahead and replace that with P in the second equation. So if I was to rewrite that second equation, I think I can make it so that I can get at least this part on the screen. It would be N times $1.50 plus P, which is 95 minus N. Be careful, not minus an N, times $1.95. And that equals $171.75. All right, so if I go ahead and distribute the $1.95 to both of these, I'm going to multiply by N and by the 95. This equation would become, and I'm going to switch the orders here a little bit. It's going to be 1.5 N plus, let's see, if I multiply 95 times 1.95, I believe I get $185.25, and then minus 1.95 N also, right? Because I've eliminated the P's, I've just got N's because of the substitution. And over here on the other side, that is $171.75. So if I combine these N's, right, I've got 1.5 N and then minus 1.95 N, that is negative 0.45 times N. And then, of course, I'll just write the 185.25. And that equals $171.75. And now if I subtract 185.25 from both sides, I believe I get that 0.45N negative, don't forget it, negative 0.45N is equal to $13.50. And then dividing both sides by 0.45, we get $13.50 over, I'm sorry, that's not positive because it was 171.75 minus 185. So this should be a negative 13.5. And I'm going to lose that negative if I'm not real careful here. And that's usually where I make mistakes, is not being careful with signs. So I've got a negative 13.5, and I'm going to divide that by negative 0.45. So N, it turns out, is a relatively nice number. Actually, N is the number 30. So there's apparently 30 of the N's, and if you remember, N's were the number of pens. So I can come up here, the number of pens sold would be 30 pens. I'll write that in my answer blank. And then in order to figure out the number of pencils, which I used P to represent, it's just going to be a matter of taking this 30 that we found for N and plugging it into this equation. So 95 minus 30 ends up being 65. Now, I encourage you, especially with a calculator and a few moments, to just plug these two numbers into the equation and verify, or even actually into the original problem, and verify, A, when you add those, do you get 95, and B, if you take 30 times the number of pens, I'm sorry, take 30 times, let's see, the pens was $1.50, so 30 times $1.50, and then add to that pencils 65 times $1.95, it should equal $171.75. If it doesn't, then there's a problem. But it does equal that, and probably just the act of practicing checking it is a good skill. There's likely to be a problem like this on the test on Friday. This was a problem that I had you pull out and we kind of did separately. I just want to say that I have a separate video where I step through all of the calculator skills necessary to go through and analyze a series of a collection of data like this. I will be playing that video in class before the test. It may be during the beginning of class, but I'll play through that, and you'll have the opportunity to have your calculator out and check and practice with a different data set. But I do encourage you to perhaps find that video now and watch it before class. Number 4, supply all missing values for each table. Let's look at part A. Part A says that this is an arithmetic sequence, so that means that it's increasing by either adding or subtracting the same number repeatedly. If you look at this, I'm jumping from the number -12 all the way to 0 in 2 steps. So each one of those steps has to be a step of adding 6. So each time I move forward here, it's the addition of 6. So I would go from -12 to -6, add 6, I'm at 0, add 6 to that, I'm at 6, add 6 to that, I'm at 12, and add another 6, I'm at 18. So repeated addition is essentially, well, it is how we generate an arithmetic sequence. And if I wanted to, it's not one of the questions, but the equation of that would be plus 6x, and then my 0th term is -12. So each time I'm adding a new 6, so as x increases, there's another 6 that's being added. So y equals 6 times x minus 12. The next sequence is geometric. And you can see that it's starting at the number 200. And in 2 steps, it's going from 200 down to 50. Well, if it's a geometric sequence, right, that means that it has to be because of multiplication, multiplying by the same value again and again. And the value that I'm actually multiplying by is 1/2. So from 200 down to the next value would be 100. So multiply by 1/2. And if I multiply by 1/2 again, I'm at 50. Multiply by 1/2 again, you're exactly at 25. Half of that is either 25 fourths, and 25 halves. And I was happy to see some of you wrote that, because to be honest, that I think is an easier way to write it, which is equivalent to 12.5, and that's fine also. And then dividing that again is actually just 25, and with another with another factor of 2 in the denominator, so 25 fourths, which is 6.25. So again, each time we are multiplying by the number 1/2. Now, question 5 actually says, write an equation in the form y equals ax, ab to the x power that will generate the x, y values in question 4, part B. So what we want to do is come up with an equation that fits this table in question 4. Well, one of the things you can see in question 4 is we know our 0th term, right, is 200. Well, that's what A is, right? A is our 0th term, and B is the value that we're continuing to multiply by. And I can see in this case, B is clearly the number 1/2. So because I have both the 0th term and what I'm multiplying by, it's pretty simple to write this down in this form. It would be y's are equal to the 0th term, 200, times the multiplier, right, the common ratio, 1/2 to the x power. All right, question number 6 asks us to simplify 2 expressions that involve exponents and products of exponents with different bases. We're going to go do both of those in one slide here. So let's Let's take a look at the first one. The first thing that I see when I see this is this negative second power, and I really want to deal with that first. But as I'm dealing with it, I'm also going to raise the 3abc squared to the third power also, right? So this expression is being raised to the third. And to do that, I'm going to raise each one of the factors in that to the third power. So I'm going to begin with 3 to the third. And then I've got an a to the third, and then I've got a b to the third, and then I've got c squared to the third. Well, c squared to the third is 6 factors of c, right? So that's c to the 6th power. Now I'm multiplying that by something that involves a negative exponent. So here's what I like to do. This is 1 over. Now, as soon as I do that, that negative 2 exponent, when this whole thing is moved down to the denominator, becomes a positive 2. So down in the denominator, what I have here is I have an a times b to the 4th times c raised to the positive second power. And that's going to be a lot easier to deal with. So what I'm going to do is I'm going to go ahead and raise each one of those to the second power. And when I do that, it's going to become a to the second, b to the 4th squared, right? b to the 4th, and then that's raised to the second power, would be b to the 8th power, and then finally a c to the second power. I don't like erasing things and moving around, but in this case, I'm going to erase this. I'm just going to grab this expression, and I'm just going to drag it right up to there. Now what I'm going to do is I'm going to go ahead and combine these, right? You can see I've got the product of two, kind of fractions. So numerator times numerator, the denominator times denominator. In my numerator, I end up getting 3 to the third, which is the number, it's the number 27. And then I've got an a cubed, b cubed, c to the 6th. Oops, I wrote to the second. I meant to the c to the 6th. And then my denominator has this a squared, b to the 8th, and c squared, right? A squared, b to the 8th, c squared. Now, at this point, there's quite a few things that I can simplify. So, for example, if I consider my a's, I've got an a cubed over a squared. Well, that's one factor of a left in my numerator. So I'm going to start writing, I think, my answer. I've got a 27a to the 1st power. And if I look at the b's, I've got 3 factors of b in the numerator, and I've got 8 factors of b in the denominator. If I simplify that, right, if I could just consider b to the 3rd over b to the 8th power, that's 5 factors of b left over in my denominator. So this is a b to the 5th power down in the denominator. And then the last thing I have is I have 6 factors of c in the numerator and 2 factors of c in the denominator. So that would simplify to c to the 4th power. So my answer is 27a c to the 4th all over b to the 5th. And it's very important that you write that answer in this spot so that I can see this easily. 27a to the a c to the 4th over b to the 5th power. Okay, so let's turn our attention now to part B. B has some fractions already. Then there's actually no negative exponents here, so this, in some respects, might be simpler. So let's go ahead and take the 5x squared and square that. So there's going to be 2 of those, right? Or I can think of it as 5 gets squared and then x squared gets squared. When I take x squared and square it, that's x to the 4th power. And this is over a y. And then I guess I'm just rewriting the other parts, right? 3y cubed over a 5. So if I simplify this by combining the numerators and denominators, because this is, of course, multiplication, I'm left with a 5 squared x to the 4th times a 3 times a y to the 3rd power. And down in my denominator, I'll write it as 5y. So I do have some common factors. I can see that there's definitely a common factor of 5 in both the numerator and denominator. And also there's a common factor of y. And if I eliminate those common factors, I end up with just one factor of y left over in my numerator because there's one of them is combining with this, and I'm left with one more. So it's 5 to the 1st power in my numerator. And then I've got an x to the 4th power. There is a number 3 here, don't forget it. And then I've y cubed over y is y squared. The thing that I would do for my final answer is I'd go ahead and multiply the 3 times 5. So my final answer is 15x to the 4th y squared. And again, it's very important to write it here. It's 15 times x to the 4th power times y to the 2nd power. Find the equation of the line that passes through the points -5, -5, and 5, -1. A couple different ways we can do this. One involves plugging in these actual values of the variables x and y to figure out what the parameters are. The parameters for a linear equation are m and b, or in this form we've got y equals m, which is our slope parameter, times x plus b, which is our y-intercept parameter. I'm going to go ahead and take the other approach. I'm just going to find the slope and then use that to in this equation to figure out what b and my y-intercept is. So a lot of times I'm still seeing errors with this, right? Slope is the change in the y values divided by the change in the x values. And that should be reflected as a difference in y's over a difference in the x's. Now I'm going to, for each point, start at this second point and go to the second one. And I'm going to do that for both x and y. So I'm going to start with the -1, that's with the y at the first point, minus a -5. So I've got 1 minus -5. And then following this same order, I've got a +5 minus a -5 for my x values. Remember, guys, it's x, y, and it's x, y. Now, in my numerator, that's 1 minus a -5, or 1 plus 5. I'm left with a +4, so the numerator is equal to 4. And the denominator, 5 minus -5, is actually 5 plus 5, or 10. So if I simplify my slope, I see that it's 2/5. So we have a slope of 2/5. That's one of our parameters. It's m, it's the slope. And I'm going to use that parameter now with one of the other points that I had to find out my y-intercept. In fact, I'm going to use this point, the one with the 5 and the -1. So if I plug that in, right, y is -1. So I'm just copying that down. And my slope was 2/5. And the x value at the point that I'm using is the number 5. I'll put a 5 here, and then plus b. So you can see in this way, the only thing that we have left is our parameter b, and we're going to find it. So if I simplify, -1 is equal to 2/5 times 5 is the number 2 plus b. And then to figure out what b is, I'm just going to take away 2 from both sides. So I get that -3 is what b is. So we now know both of our parameters, right? We know our slope, m is 2/5, and we know our y-intercept parameter is -3. So we can write the equation of the line, right? The equation of this line is y equals positive 2/5 x, and then minus the number 3. So 8 says solve each equation, include a check for your solution. Let's start with A. Of course, looking at A, my first thought is let's get rid of these parentheses. So when I use the distributive property, this becomes 6x plus 15. I know you can do that. And then I've got a minus 3x plus 7. Let's continue to simplify this side further. When I combine the 6 times x and the minus 3x, that's just simply a 3x. And then also let's combine the 15 and 7. That's a plus 22. So that is the left-hand side. Over on the right-hand side, we can make the following simplification, right? I can combine the 2x and -4x. So I have a -2x when they're combined plus 7. Let's see. I'm going to add 2x to both sides, and I'm adding exactly the same thing to both sides, just 2x. On the left-hand side, I end up getting a 5x plus the 22 that was already there. And on the right-hand side, when I add the 2x to the -2x, it's just plain old 7. Next, I'm going to subtract 22 from each side. If I have 7 and I subtract 22, over on this right-hand side, I end up getting 7 minus 22 is -15. And then Yeah, that's correct. And then finally, I'm going to divide both sides by 5. And when I do that, I get that x has to equal the number -3. So there's a room for the answer way down here, right? X is the number -3. However, it does say include a check for this problem. So it's a good idea to do that, and I'm going to do that here in the video. So this is going to become I'm just going to kind of think through this. This is going to be a -3, and this is going to be a -3, and I'll just write the results below. So if x is -3, on the left-hand side, I end up getting a -6 plus 5 in the first set of parentheses. -6 plus 5 would be a -1. -6 plus 5 is a -1. And if I multiply -1 times 3, I end up with a -3. And then to that, I'm going to add a -3 times -3, which would be +9. -3 is x times -3 is +9, and then finally +7. So if I evaluate that, that's like 16, and then 16 minus 3 would be a +13. So on the one hand, I've got a 13. On the other hand, if I plug in, there's x's in two spaces here and here. In the first instance, 2 times -3 would give me -6. And then I've got a +7. And then -4 times -3 should give me a +12. So if I combine -6 and 7, that's 1, and 1 plus 12 is 13. So I can see that indeed when I plugged -3 into the equation, both the left-hand side and the right-hand side were 13. So the answer indeed checks. X is 13. Let's come over here and look at part B. On B, I'm going to go ahead and use fraction busters, and I'm going to multiply both sides of this by the number 4 to eliminate these fractions. So when I do that, and I'm going to write it out first, right? I've got a 4, and I can write if times 1 if I want. 4 times 1 over 4, and then x, plus 5 times 4, plus 3 times, oh, whoops, not plus, it equals, sorry, equals 3 times 4, which is, 12, over 2, plus 4 times 2x, and then finally minus 4 times 14 is that's -56. So now that you can see, I didn't show it in that step, right? I should show that. 4 times, actually, let me do this, right? -14 times a 4. So I want to be real clear. Every single term on both sides end up with a brand new, fresh factor of 4. And you can see every single one of them did. Now, I can go through and simplify those now that it's real clear that I did add a factor of 4 to each term. And remember, guys, terms are those things that are separated by plus or minus symbols. So you can see the left-hand side had 2 terms. There's this plus. And the right-hand side has 3 terms because I've got a plus and then a minus there. So every single term got a fresh factor of 4. Fraction busters. So what does it become? Well, 4 over 4 is 1, so I've got an x plus 20 over on the left-hand side. On the right-hand side, I've got 12 divided by 2, which is 6, plus an 8x. And then finally, minus 4 times 14 is -56. If I simplify by combining a couple things here, I guess I'm going to go ahead and add 56 to both sides and subtract and subtract 6 from both sides. Actually, I'll do this. Well, I could write a lot of steps here. Let's go ahead and I'll just take away an x from both sides. That's simple. So that gives me a 20 equals. And what I'm going to do now is I'm going to go ahead and combine the 6 and the -56. So that's going to be a -50. And then don't forget I've got plus 7x. Now I'm going to go ahead and add 50 to both sides. So that'll give me 70 over here equals 70 times x. And then finally, I'm going to divide both sides by 10. So I can see without a lot of fuss that x has to be 10. And I'll just write that here. Now I should, again, it's suggested, it's required actually for this problem that I show a check. So let's go ahead and do that. To show the check, I'm just going to plug in mentally some values of x here and verify that the left-hand side and the right-hand side are the same. 1/4 of 10 is 10/4, which doesn't sound very gratifying, but let me go ahead and write that. So I've got 10/4 plus the number 5. And over on the other side, I'm wondering if it's equal to, I've got 3/2 plus 2 times 10 is 20, and then minus 14. So let's look at this a little bit closer. 10/4 plus, well, 10/4 is 5/2, isn't it? So I can write this 5/2 plus 5, and that equals, let's see, 20 minus 14 is 6. So I've got 3/2 and then plus the number 6. And I'm starting to see that, yeah, it looks like we've got it here, because if I consider 3/2, that's 1.5. So I know that this is actually going to be a 7.5. And on the other side, when I do that, 2 goes into 5 twice with a half left, with 1 left over, a remainder of 1. So that's 2 1/2 plus 7 is actually also 7.5. So I can see the left-hand side and the right-hand side are both the number 7.5, which is always blissful, because that means that my answer of 10 was indeed correct. All right, the two triangles below are similar. Find the length of the side labeled x, which is right here, right? So we need to find this x. So if I think about it, I can, well, there's a lot of ways I can do this, right? If I'm doing a transformation from this to this, right? I am taking the old, this is my old figure, OLD, and this is the new one. And if I take a new dimension and divide it by the old, I get my scale factor. So my new dimension is 3, and the one that goes with it that's old is 6. So my scale factor is the number 1/2. And if I want to move from the large one to the small one, I'm just multiplying by that scale factor of 1/2. This is one way to think about it. That means my answer has to be 15 times 1/2, or 7.5. Another way that you can think about this is you can set up a proportion. So you could say, for example, 3 is to 6 as x is to 15. And that certainly works, because you end up getting that 6 times x is equal to 45. And when you take 45 and divide by 6, you also get that x has to be the number 7.5. Find an equation of the form y equals a times b to the x that goes through these two given points. And I've set this up for you. I say below, use the system below to help find the parameters a and b. Remember, a is the 0th term and b is our common ratio, or our multiplier, so that you may write the equation, right? So I need to write an equation in this form, and to do that, I just need to figure out what a and b is, and this system of equations is going to help me do exactly that. Well, I begin by noticing in the first equation, it's pretty simple to get a alone by dividing both sides of that by b. Divided by b cubed. 40 divided by b cubed is exactly that, 40 divided by b cubed. And if I have b cubed divided by b cubed, it's just simply a, which is beautiful, because this turns out to be a perfect substitution for a into the second equation. So that in that second equation, I can go ahead and replace the a and get 1280 equals a, which is 40 over b cubed, times b raised to the 8th power. So looking at this very studiously, I know that b to the 8th is the same thing as b to the 8th over 1. So it's a little fraction multiplication problem here. So I've got 40b to the 8th in the numerator, and my denominator is b cubed. And I can simplify that by simply canceling out common factors of b, or thinking of a giant one, b to the 3rd over b to the 3rd. Anyways, it becomes that equals 40b to the 5th power, and that's equal to 1280. Now, what's nice about this is I can quickly divide by 40, and when I do that, I get b to the 5th power alone. So b to the 5th power if I divide both sides by 40, is the number 32. 32 is b to the fifth. I happen to know that's the number 2. If you don't, that's okay. Remember, you can use your calculator to evaluate this. Basically, to do that, you would hit the number 5, and then you would press the button that says Math, and then inside of there, it's the option that looks like this. It's the xth root. So you would pick that option. And then once you've got that option picked, you're going to enter the number 32 and then equals. And your calculator will tell you, hey, the fifth root of 32 is the number 2. In other words, 2 times 2 times 2 times 2 times 2 is 32. That's 4, 8, 16, 32. Sure enough. So I know that b is the number 2. That's one of my parameters. I also need to figure out what a is. Well, a is not going to be difficult to find because if you'll recall right up at the top here, we said, hey, a is 40 divided by b cubed. Well, I know that b is 2, so 40 divided by 2 to the third power is the same thing as 40 divided by 8, which is the same as the number 5. So my other parameter, a, my 0th term, is 5. Now that I know both a and b, I can write the equation in this form, right? It is y equals a times b to the x power. Again, y equals, we found that a was the number 5. We found that b, our multiplier, was 2, and I'm raising that to the x power. And sure enough, if I plug in both of those points, right, 3, if I plug in 3 for x, it will give me 40, and if I plug in 8 for x, it will give me 1,280. So our absolutely last 2 questions on this study team test, it says complete each triangle congruence statement, and then it says give a triangle congruence condition that can be used to establish that the triangles themselves are indeed congruent. So let's remember what our triangle congruence conditions are. They are side, side, side. You're showing that there are 3 pairs of congruent sides. The triangles must be congruent, or side, angle, side, or angle, side, angle. Also, you can have angle, angle, followed by a non-included side. And finally, the last valid triangle congruence condition we have is hypotenuse leg. Of course, be careful. This does require that you have a right-angled triangle. If you don't have a right-angled triangle, hypotenuse leg doesn't apply. So let's take a look at the first one here. It says triangle box is congruent to. Well, if I'm looking at it, box is going from here to this to this. So if I make the same jump in that order, here's this angle, and then jump to the other angle, and then jump to the angle without a mark. So that's TPY. So it would have to be triangle TPY. So triangle box is congruent to triangle TPY. And when you look at the reason why, right, you can see that I've got in each of them, there's an angle. Here's this angle and this angle. And then they also, oh, look, I'm changing my color pen. And then they've also got this angle, and they've got this angle. And then finally, notice that they've got this included side, this side in between them. That's why our triangle congruence conditions for this one is angle, and then the side, and then the angle congruence, right? So angle, side, angle. And then in B, triangle MIT is congruent to triangle blank, blank, blank. So MIT is going from this to the right angle and then straight up to here. So we'll do the same thing for the other triangle, N to the I and then up to the T. So it's triangle knit, N, I, and then T. So triangle MIT is congruent to triangle NIT. And then our reason, if you look at it, there's not a lot in this diagram, right? We do have the right angles, and we also share this side. So by the reflexive property, right, we know that those are both congruent. And that's it. Well, we're fortunate. We do have these. This is a hypotenuse, right? So we have a pair of congruent hypotenuses because they are indeed right triangles. And also they share a leg. So they share this one leg. So by hypotenuse leg, HL, they are congruent to each other. So our triangle congruence condition here is HL congruence. Well, that's it for the study team test. I hope that you use this judicially and that you are prepared for the test on Friday.